Good morning, students. Relative extrema, exercise 7.6, second problem. Find the intervals of monotonicities and hence find the local extremum for the following functions. Okay, f of x is equal to x by x minus 5. So, local extremum and intervals of monotonicities, if you want to find, your first step should be you have to find the first derivative. So, f dash of x. You see that numerator and the denominator are the functions of x. So, you have to use the quotient rule. Okay. So, in the quotient rule, the denominator, that is b term, has to be written x minus 5 the whole square. Here you have to write v, so x minus 5, and you have to differentiate u. So, the differentiation of x is 1. In between you have to write minus and u has to be written as it is, and you have to differentiate x minus 5. So, the differentiation of x is 1 and minus 5 is a constant whose differentiation is 0. So, here I have written 1. So, when you expand x minus 5 minus x, so x and minus x getting cancelled. So, your f dash of x is equal to minus 5 divided by x minus 5 the whole square. In next step, you have to find the critical number. So, the critical number at which f dash of x is equal to 0 or f dash of x does not exist. You see that your f dash of x is never equal to 0. So, when equal to 0, x minus 5 the whole squared is equal to 0. So, minus 5 is equal to 0. It is absurd. So, that's why I have said f dash of x is never equal to 0. Okay. And you see now, you look at the denominator, here you are having x minus 5. If you substitute x as 5, the whole term does not exist because the denominator is 0. So, f dash of x does not exist when x is equal to 5. So, this is also a critical number. So, using this critical number, you are going to write the interval from minus infinity to plus infinity. So, we will consider minus infinity to 5 and 5 to infinity. So, intervals, and you have to check the sign of f dash of x and you have to write about the monotonicity, that is whether it is increasing or decreasing. Okay, I will consider the first interval minus infinity to 5. You take any point, so we will go for, we can take 0. Okay, so when you substitute here, what will come? This the denominator x minus 5 the whole square. So, when you square any term, it is positive, isn't it? So, the denominator is positive. The numerator you are having the constant minus 5. So, it will be negative. So, if it is negative, the function is strictly decreasing. Okay. We'll consider the next interval 5 to infinity. You take any positive value which substitute the denominator, you are having the square of x minus 5. So, it is always positive. So, the numerator is a constant minus 5. So, here it will be negative. So, strictly decreasing in from 5 to infinity interval also. Okay. So, this function f of x is strictly decreasing in minus infinity to 5 and 5 to infinity. So, we have completed the intervals of monotonicity. Okay. Next one, you have to find the local extremum. So, local extremum means your f dash of x changes positive to negative or negative to positive. Here in this interval, there is no change. There is no change in the sign. Fully throughout it is negative. So, we have to say f dash of x does not change its sign as x passes through 5. So, therefore, this f of x has no local extremum. That means maximum, minimum. The function does not attain local maximum and minimum in the interval. Okay, come to the third subdivision. F of x is equal to e power x divided by 1 minus e power x. So, first step you have to find the first derivative. Again, here also you have to use the quotient rule. So, it is 1 minus e power x the whole square. So, here you have to write v, that is 1 minus e power x. Next, you have to differentiate the u, that is e power x. So, when you differentiate e power x, it is e power x. minus, according to the quotient rule, in between you will have minus, then u has to be kept as it is, that is e power x, and you have to differentiate the denominator. So when you differentiate 1, it is 0. So in between you are having minus, e power x differentiation is e power x. So when you expand 1 into e power x minus e power x into e power x is e power 2x, and you see that here minus into minus plus e power x into e power x is e power 2x. So these two getting cancelled, you are getting e power x divided by 1 minus e power x the whole square. So when e equal to 0, so the denominator is equal to 0, e power x is equal to 0. So the exponential function will not become 0. Okay, so e power x is never equal to 0. Okay, so see now the denominator, when you substitute x as 0, what is e power 0? That is 1. So what is 1 minus 1? 0. So the denominator 0 means f dash of x does not exist. So when x is equal to 0, your f dash of x does not exist. So x equal to 0 is a critical point or critical number. So using this we have to write the intervals. So starting from minus infinity to 0 and 0 to infinity. So here we have to check. See now intervals and f dash of x and the monotonicity. F dash of x means sign of f dash of x. So minus infinity 0 and 0 to infinity. The intervals I have written. Take the first interval minus infinity to 0. You take any negative point. Okay, and you have to substitute in where? F dash of x. Okay, you see the denominator. Whatever you are substituting, it is square is there. So it is positive. Okay, and whether x is positive or negative, e power x will not be negative. So e power x is positive when x is negative or positive. Okay, so therefore whatever x value, that is positive or negative, your sign of f dash of x is positive. Okay, see again I will explain. You see the reason. Here in the denominator it is a square of 1 minus e power x. So always it is positive. So x is negative also. If you substitute x as negative or positive, e power x is positive always. So therefore here in both the interval the sign of f dash of x is positive. So therefore the function is strictly increasing. So your f of x is strictly increasing in minus infinity to 0 and 0 to infinity. So here also there is f dash of x does not change the sign as x passes through 0. So therefore it does not have no local extremum. The function does not attain local maximum and minimum. Okay, come to the fourth subdivision. F of x is equal to x cube by 3 minus log x. Okay, you see log x is there. So the log x is defined only when x greater than 0. But here this function is defined only when x greater than 0. So that's why here I have written x greater than 0. So as usual we have to proceed f dash of x. So see the first term 1 by 3 is a constant. So I have written in the denominator 3. So x cube when you differentiate it is 3x squared. Okay, minus. What is the differentiation of log x? It is 1 by x. This 3 getting cancelled. So x squared minus 1 by x. If we take LCM, LCM is x. So it will become x cube minus 1. What's the next step? You have to equate f dash of x is equal to 0. So when you equate, the denominator into 0 is 0. So x cube minus 1 is equal to 0 means x is equal to 1. The remaining two roots are imaginary. We are not going to consider. So 1 point we are getting. What is that? X is equal to 1. And look at the term. It is x cube minus 1 divided by x. So in the denominator you are having x term. So if we substitute x equal to 0, the denominator is 0. So f dash of x does not exist. So when x equal to 0, f dash of x does not exists. So these 2 points are critical numbers. Using the points we have to form the interval. So the intervals are, we have to usually will start from minus infinity to 0 and 0 to 1 and 1 to infinity. Here I have written only 0 to 1 because the given f of x is defined only when x greater than 0. So when x is less than 0, the function is not defined. So we need not consider from minus infinity to plus infinity. We can consider the interval from 0 to 1 and 1 to infinity. So I'll go for 0 to 1. So the intervals and sine of, you see that your f dash of x having two terms, one is x cube minus 1, another one is x. Okay, so first I'll take sine of x cube minus 1, what it is, then the sine of the whole term f dash of x. Okay, see now, first interval 0 to 1. So what point we can consider? We'll go for positive values only. So I'll take half the whole cube. That is, what is it? 1 by 8. 1 by 8 minus 1. What's answer? It is minus 7 by 8. Isn't it? So it is negative. So the numerator is negative and the denominator is positive. So the sign of f dash of x is negative. So therefore the function is strictly decreasing in this interval. And consider the next interval 1 to infinity. So 1 to infinity we can take 2. So 2 cube is what? 8. 8 minus 1. 8 minus 1 is 7. So it is positive. So the numerator positive and the denominator is positive. So the sign of f dash of x is positive. So therefore it is strictly increasing. So we can write the monotonicity of the function as f of x is strictly increasing in 1 to infinity and strictly decreasing in 0 to 1. Okay, you see that only two intervals. So your f dash of x changes the sign negative to positive when x passes through 1. Okay, when x passes through 1, your f dash of x changes negative to positive. So if it is negative to positive, means you will get a minimum. So the function f of x has attains local minimum at x is equal to 1. Okay, we located the point where you are getting the minimum, x is equal to 1. So you have to find the what is the minimum value. So that is y value. So you are going to find f of 1. What is your f of x? F of x is equal to x cube by 3 minus log x. So in the place of x you have to substitute 1. So see that here your f of x, this is your f of x. So here you have to substitute 1. 1 cube is 1. 1 by 3 minus log 1. So what has to come? 1 by 3 minus 0 because log 1 is 0. So your answer is 1 by 3. So this is the minimum value. This value is attained at x is equal to 1. Okay. Come to the fifth subdivision. F of x is equal to sin x cos x plus 5, where x belongs to 0 to 2 pi. They have given the open interval 0 to 2 pi. That means 0 to 360 degree. So I'll consider the function f of x. So I multiply and divided by 2. So when I multiply 2, it is 2 sin x cos x. That is the formula for sin 2x. And the denominator 2 I have written. So it will become 1 by 2 sin 2x plus 5. I rearranged f of x. Okay. And next you have to go for f dash of x. So you have to differentiate with respect to x. So 1 by 2 is a constant. Sin 2x, how to differentiate? So this 2x has to be kept as x using chain rule. So sin x. So the differentiation of sin x is cos x. So it is cos 2x, and which is kept as x, that has to be differentiated again. So 2x, the differentiation of 2x is 2. So sin 2x differentiation is cos 2x into 2. Okay, and plus 5 is a constant whose differentiation is 0. So this 2 and here 2 getting cancelled. So f dash of x is equal to cos x. What will be the next step? You have to find the critical number. So for that, f dash of x is equal to 0. So cos 2x is equal to 0. So 2x is equal to, when the cos term will become 0, it's an odd multiple of pi by 2, the cos will become 0. So it is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. It goes on. So that is equal to 2x. So you have to find out x. So x is equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, etc. So we have to find the x value within this open interval, that is 0 to 360 degree. So what are the values I'll take? Pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, 9 pi by 4 and all. It is above 360. So I'll stop 7 pi by 4. These 4 values belongs to the open interval 0 to pi. Open interval 0 to pi. Now what you have to do? You have to, these are the critical numbers. So we have to consider the interval and check the values. So we'll go for the intervals and you have to go for f dash of x. What is your f dash of x? F dash of x is equal to cos 2x. And you have to check the sign of f dash of x and you have to write the monotonicity. Okay, so what's the first interval? First value is pi by 4. Next one 3 pi by 4. Next 5 pi by 4. Next 7 pi by 4 and up to 2 pi. So I'll start from 0 to pi by 4. Pi by 4 to 3 pi by 4. 3 pi by 4 to 5 pi by 4 and 5 pi by 4 to 7 pi by 4, 7 pi by 4 to 2 pi. So all the intervals is consider starting from 0 to 2 pi. Okay, so now what you have to check? Your f dash of x. F dash of x, what we have found? Cos 2x. So 0 to pi by 4, that is 0 to 45 degree. So here you can write only the sign of f dash of x. Okay, so here for your understanding I have taken some values. So x is equal to 30 I have taken. So cos 2 into 30, so that is cos pi by 3, that is cos 60 degree. The cos 60 degree is 1 by 2. So what is the sign of f dash of x? It is positive. So in this interval the function is increasing, that is strictly increasing. Next interval 45 to 3 pi by 4. What is 3 pi by 4? It is 135. Okay, 45 to 135. Okay, so here I'll take x is equal to pi by 2. So 90 degree I'll take. So cos 2 into pi by 2. 2 getting cancelled. You are getting cos pi. What is cos pi? It is minus 1. So what's answer you are getting? It is negative. So f dash of x is negative. So it is strictly decreasing. And go for 3 pi by 4 to 5 pi by 4. What is 5 pi by 4? It is 225. So it is 135 to 225. So I'll take x is equal to pi. Okay, when you substitute here cos 2 pi, what is cos 2 pi? It is 1. So it is positive. So strictly increasing. And next 5 pi by 4 to 7 pi by 4. What is it? It is 225 to 315. What is it? 225 to 315. So we can take x is equal to 3 pi by 2. What is it? 270 I have taken. So 3 into pi by 2. So it is 270. So when you substitute cos 2 into 3 pi by 2. 2 getting cancelled. So you're having cos 3 pi. What is cos 3 pi? It is minus 1. So here it is negative. So the function is strictly decreasing. And next one 7 pi by 4 to 2 pi. Okay, 7 pi by 4 to 2 pi. 2 pi. So what is I have said? It is 315 to 360. Between the interval we have to consider. I'll go for 11 pi by 6. That is, what is it? 11 pi by 6 is 30 into 11, 330. So when you substitute here cos 2 into 11 pi by 6, that is cos 11 pi by 3, that is cos 660 degree. So it is one rotation is over. So when you subtract 360 from this, it is cos 300. Cos 300 can be written as cos of 360 minus 60. Okay, so 360 minus 60, that is 300 lies in the fourth quadrant. So your cos is positive. So therefore cos 60 degree. What is cos 60 degree? It is 1 by 2. So it is positive. So it is strictly increasing. Okay. So see now. So your f of x is strictly increasing in 0 to pi by 4 and 3 pi by 4 to 5 pi by 4 and 7 pi by 4 to 2 pi. And the remaining intervals, the f of x is strictly decreasing. So here I have written. Okay. So f of x is strictly decreasing on pi by 4 to 3 pi by 4 and 5 pi by 4 to 7 pi by 4. Okay. You see now from this tabular column, your f dash of x changes the sign from positive to negative. Okay. Positive to negative when x passes through pi by 4, and you see that 5 pi by 4. Okay, so these two values, what is it? When x is equal to pi by 4 and x is equal to 5 pi by 4, your f dash of x changes from positive to negative. So if it changes positive to negative means your f of x has local maximum at these 2 points. So we have to find what is the local maximum values. Okay, so we have to substitute f of pi by 4 and f of 5 pi by 4. You see that the f of x is sin x into cos x plus 5. So sin pi by 4 cos pi by 4 plus 5. Sin pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2 plus 5. So it is 5 I have written in the front. 1 by root 2 into 1 by root 2 is 1 by 2. So when you take it LCM, it is 11 by 2. Next f of 5 pi by 4. So it is sin 5 pi by 4 cos pi by 4 plus 5. So see that 5 pi by 4, it is 225. So it lies in the third quadrant. Both are negative. So minus 1 by root 2 into minus 1 by root 2 plus 5. So when you multiply these two, 1 by 2. So 1 by 2 plus 5. Again the same result comes. So it is 11 by 2. Okay. So the maximum values are obtained at x is equal to pi by 4 and x is equal to 5 by 4. The maximum value is 11 by 2. And you see that from the tabular column, now your f dash of x changes negative to positive. You see that negative to positive when it passes through 3 pi by 4. And see the next one, negative to positive when x passes through 7 pi by 4. So 3 pi by 4 at 7 pi by 4, your f of x attains local minimum. So we have to find the minimum value. So f of 3 pi by 4. So it is sin 3 pi by 4 cos 3 pi by 4 plus 5. Okay. So what is it? It is 135 degree. So it will become, so it lies in the second quadrant. So sin is positive. Your cos is negative. So minus 1 by 2 plus 5. If you take LCM, 10 minus 1, that is 9 by 2. And you have to substitute f of 7 pi by 4. Okay. So when you substitute f of 7 pi by 4, you see that sin 7 pi by 4 cos 7 pi by 4 plus 5. 7 pi by 4 is, 7 pi by 4 is nothing but, what is that? It is 315 degree. So what is it? 315 degree. So it lies in the fourth quadrant. In the fourth quadrant, sin is negative. So it is minus 1 by root 2. Your cos is positive. So it is 1 by root 2 plus 5. So when you multiply, it is minus 1 by 2 plus 5. If you take LCM, it is 9 by 2. So this is the minimum value which is obtained at 3 pi by 4 and 7 pi by 4. So the maximum value is what? It is 11 by 2, which is obtained at pi by 4 and 5 pi by 4. Thank you, students.